Why is the sun's atmosphere so hot? You might think this is an odd question, but it is one that has baffled scientists for more than 70 years. While the surface of the sun is a mere 5,000 degrees, its outer atmosphere, or corona, is an average of 2 million degrees, 400 times hotter. So it's as if the sun were a campfire, and when you walked away from it, you got hotter instead of colder. Clearly, there's some unconventional physics happening around our star. My research is focused on finding a solution to this paradox, commonly known as the coronal heating problem. The hypothesis that I am testing is the theory of nanoflares. The idea is that thousands or even millions of tiny explosions powered by the sun's magnetic field release enough energy to keep the corona at its oddly high temperature. So how do we find such tiny explosions? It turns out that nanoflares produce X-rays, just like the machine in your doctor's office. Unfortunately, these X-rays are so faint, we need extremely sensitive instruments to see them. Fortunately, I am working with an extremely sensitive instrument. The new star satellite, as seen on my shirt, was designed to detect X-rays from black holes at the far reaches of the universe. So it has no trouble seeing X-rays from the sun. In fact, we have to be careful not to point at the sun when it's too bright, or the instrument will go temporarily blind. I have analyzed new star data to look for nanoflares in quiet places on the sun, where they are easiest to detect. My first search found absolutely nothing. Now, while this isn't the most exciting result, I am using this data to set limits on how bright nanoflares could be and still avoid detection. In addition, the sun itself is going to help us get better measurements. How, you might ask? Solar activity increases and decreases like clockwork in an 11-year cycle. And since we are entering the quietest part of this cycle, nanoflares, if they exist, will be easier to see in the next few years. Will these elusive explosions help us solve the age-old coronal heating problem? For the sake of my dissertation, I certainly hope so. But whether or not new star sees nanoflares, it will see things on the sun that we have never seen before. We are exploring a new frontier in our own cosmic backyard. Thank you.